what is consensus algorithm or consensus mechanism in a nutshell. So as we say, consensus algorithm aims for creating the kind of agreement in a group. So the focus is how you can create a kind of consensus in the group, and you ensure there is a single version of truth being maintained in a group. So it creates a network structure or process that allows a group of independent system to agree on a single version of truth. So as we say, consensus algorithms, they are not unique only for blockchain technology, but then they have been there in other in other aspects as well. So consensus algorithm are important fundamental ways of having an agreement on a single source of truth. So the structure of the network as we understand it from the consensus algorithm. So let's try to dive it deep. So a consensus algorithm is certainly a piece of code that helps you to govern how a blockchain operates. So it basically sets the kind of rule that all the participants must follow to process their transaction. So the consensus algorithm in a network creates a network structure and the overall processes that allow a group of independent systems to agree on a single version of truth. So each and every node might put a copy of data, but then there has to be an agreement that how you arrive at a single version of truth in case of any conflict arising across. So your consensus algorithms are certainly not unique to blockchain technology, but then they are also the foundation of all the kinds of blockchains. So they are the set of rules that governs how each blockchain function will work in a nutshell. So it is certainly essential to understand the different types of common blockchain network structures and various consensus algorithm that dictate their structure. So we should be able to understand the various types of consensus algorithm. So having the understanding of these structures will certainly empower us to make the informed design decisions when building any kind of application and processing any kind of transactional data. So it is an important aspect that we should be able to understand the piece of code which is a consensus algorithm, and it governs how the overall blockchain will operate. So let's try to find different types of consensus algorithm. So these are few of the types of consensus algorithm. They are just a handful types of consensus algorithm. They are multiple types as well. So the first one is, say, proof of work, as we call it, POW. So when a user initiates a transaction, a miner or supercomputer, they try to solve a problem or puzzle to verify it. So in the case of proof of work, a consensus algorithm, so it is these miners who solved some mathematically tough problems to ensure that they get the right for those coins. So that's a proof of work consensus algorithm. So the proof of stake consensus algorithm is again one of the way. So in this, a user is encouraged to spend more until she becomes a validator to create a block. So there are stakes involved in it. The user is encouraged to spend more and more so that they become the validator for creation of the blocks. That's a proof of stake. The third is the delegated proof of stake. So same as a proof of stake, but the user with more coins will get a more rights or more voice, and they can elect the overall witness. So it's like a how much stake you have, and it can be determined by the overall coins you possess and your voting right will be based and defined on those coins which you have. So that's a delegated proof of stake. The next one, as we call, is your proof of authority. So as we say proof of authority, so both the both uses, it uses proof of stake and proof of work to ensure the reward points are there on time. So that's a proof of activity. So that's how you can ensure the proof of activity consensus algorithm is being worked upon. So similarly, we have proof of elapsed time. So we have proof of capacity. We have proof of space. We have proof of burn, and there are various other hyperledger consensus algorithms as well. So if you say the proof of elapsed time, so it is similar to the proof of work, but the difference is that it focuses more on the overall consumption. So if you then see the practical benzyl fault tolerance, which is PBFT, so in that you will have the benzene time, which is used by a particular sequence to keep the rogue users at the base. That's a practical benzene fault tolerance, which is called PBFT. Similarly, we have simplified benzene time fault tolerance, which is SBFT. In this, a simple validator can bundle the proposed transaction and create a new block. So similarly, we have directed acrylic graphs, which is, so as we say DAG, they don't have any blockchain data structures and can basically handle the transactions asynchronously. So as we say, the proof of activity we discussed, it is using both the proof of stake and proof of work to ensure the reward points are there on the time. Similarly, the proof of importance, so it in the case of proof of importance, users that frequency send and receive the transaction will get paid for that. So it all depends on the frequency of send and receive transactions, and users get paid based on that. So proof of capacity, it basically utilizes, so if you are using proof of capacity, so using this protocol, you can utilize the capacity of storage space of a user's hard drive. So that's how we call that as a proof of capacity. Similarly, you have proof of burn, which in the case of proof of burn, user basically sends the coin back into their wallet that they cannot recover from, from which to get the rewards based on the amount. So you try to get those rewards based on the kind of coins which you have there in your wallet. So again, proof of weight is basically similar to proof of stake, but then the difference is that it depends on the various other factors called the weight. So you assign different weights to the activity which is there across. So there are different types of consensus algorithm meant for working out on your working out in your blockchain. So these are few of these examples.